Hey, what's up, and welcome back to the multiverse of 100 plus data science project series. In this video, we are going to discuss about the brain stroke predictions using machine learning. This is an advanced type of machine learning projects where we're going to discussing about the data analysis, data visualizations, and also we are going to building here the machine learning model from the scores. This is the web applications that we're going to creating on this website. This is an end-to-end projects, and that's called the stroke predictions using machine learning. And also you can see here it having some input features. You can give the input. So let's say give here, let's say 16, and let's say male, and let's say average glucose level, let's say 78.96 or 89, and hypertension, let's say it have hypertensions, and heart disease, let's say heart disease, and iberberate, residence area urban, smoked, and let's say it's self-employed, and let's say BMI, let's say 32. And if I click on this one, and you can see likely to be stroke. Okay, so these are the applications that we are going to building in this tutorial. So this tutorial should be more awesome, so follow along with me and try to making this one and add it to your resume. So without any wasting time, Har Har Mahadev, we can start with the tutorial. In order to building our machine learning model, we're going to choose the dataset from the Kaggle. This is nothing but on competitions. That's called binary classifications with the tabular stock prediction dataset, which are having the sample submission. You can submit on here, and it having the train.csv. We have the test.csv. So simply I am going to go on here and create an account on that, and after that I'm simply going to click on download, and it will download the dataset on your directory. Now it's time to creating our machine learning model and play with our data. Okay, so let's go. Well, so first thing first, so what I can do is simply going to import the pandas and the numpy library, as well as you're going to load the dataset from our directory. So let's import pandas. So let's say import pandas as pd. Then I'm going to importing here the numpy as np. Let's say numpy as np. And after that, I am going to load the dataset from our directory. So in our folder, we have three dataset. One is called train.csv, test.csv, and as well as sample submission.csv, which one is a submission file. Then it will submit on the our Kaggle competitions. Okay, so let's say train underscore df, and then you're using here pd.read underscore csv. Then inside there, I need to giving here the path of that. So path is nothing but train.csv. Then after that, let's try to run it again so that the warning should be gone. And then we have the test df. So let's say test df equal to pd.read underscore csv is nothing but the test.csv. Then we have the submission file. Let's call subdf equal to pd.read underscore csv, and inside there let's giving here the sample underscore submission. Okay, submission dot csv. Now you can see here our dataset is loaded correctly. Now let's try to do some analysis on the data and try to preview our data first. So let's say train df dot hat. Then you can see, okay, I need to remove here 0. You can see that how many rows and how many columns are available on here. So you can generally see the 5 rows, but it having id, gender, age, hypertension, heart disease, your merit, work type, residence type, the average glucose level, BMI, body mass index, smoking or not. Then you have a status called a stroke. So let's say check the stroke. Let's say train df of a stroke dot unique. Yeah. Now you can see here we just having two values 0 and 1, which one is nothing but my target class. Now the question is it a supervised machine learning problem or an unsupervised machine learning problem? Yeah, it's obviously an unsupervised machine learning problem. Why? Because our target column is already given. Now which kind of classification is it? Is it binary classifications or the multi class classifications? This is the binary classification because it having the just only two classes, 0 and 1. Okay, now let's try to explore it more. Let's say train df.info. So you can see here we got some information regarding our data set. ID is nothing but the integer, and it having 15304, and also gender, age, hypertension. You can see here the data types of that. Data types objects mean this is nothing but one string. That's mean a categorical variable. Which one we need to handling it out. Okay. So I have some problems. थोड़ा बुखार हो गया तो आवाज में थोड़ा प्रॉब्लम हो सकता है. Okay, just make it considerable. Okay, now what I'm going to do, I am simply going to describe it right now. Okay, let's taking some shell. and after that I'm going to describe it. Let's say train df dot describe, train df dot describe. Okay, it's nothing but descriptive analysis of your data. Then you can see count of the each of the numerical column, not categorical. You can see the gender is categorical column and it's not available on here. Then mean, standard deviations, minimum, 25% percentile, 50% percentile, 75% percentile, and the maximum value of that. Cool. You can also make it transport. Let's say transport. Then after that, you can see here it will transport this whole matrix, and you can see count, min, standard deviations, and the minimum, maximum in this directions, y direction. Okay. Now let's try to use here our train df and try to checking here number of unique. You can also press the tab key from your keyboard. Okay, you can see here it will give me the auto suggestions. If I using here the n unique, then you can see how many unique number are here. We can see that unique number in id, it having it id should be the unique. That's why id is nothing but 15304. But we also see here in the glucose level it having some unique value. In the BMI it having some unique value, but most of the don't have any unique value just for the hypertensions or the stroke. Okay, because we know that a stroke, inside a stroke we just having the two values. That's mean in the age and the average glucose in the BMI with having some different types of value. Okay, or not unique value. So we can play with them and try to do some data analysis on that, right? So now what I can do, I am simply going to also checking for the duplicate value. So let's say train df dot duplicated, okay, duplicated a dot sum. Okay, we can see that we don't have any duplicated value as well. Okay, we don't need to handle it out, right? We don't have any missing value, we don't have any duplicated value. So that's mean we don't need to handling our missing value and the duplicated value as well. Now let's try to clean our data. Okay, it's called the data cleaning. Okay, just like you remove your toxic girlfriend from your life like that way. Okay, you need to clean the data. Okay, just jokes apart. Okay, so now let's try to do the data cleaning. Okay, so what I can do, I already see this data in our data. If I see that in the A sections, you can see it having some point types of value. Okay, point types of value. So let's start to checking this out. So let's insert our train df in our A sections, in our A's, in our H columns. So we have to checking first unique value, how many unique value have it, and also let's try to making one list. Let's say two list, and after that let's try to shift enter. Okay, and we can see that it having some value called 1.4, it having some value called 0.4, it's having some value 1.56. For the age is not to be considered because age should be one kind of integer number. It can be 2 year, it can be 3 year, it can be 4 year, it can be 5 year, not 1.5, not 1.6, right? So we need to handling this out and we need to also cleaning this out, just like your toxic girlfriend. Okay, sorry for that, it can be toxic boyfriend as well. Then okay, let's just short it. Then what I can do, I can short it out. Okay, any problem, any problem, short it. Fine. Now you can see here it shorted this list 0.08, 0.16, 0.24. That's mean nothing but 24 days hope so, or 30 32 days, or the 4 days like this way. Okay, you can let's say checking for the, let's say first 12, then you can see it correctly. Okay, now it's look good. It's also taking some, it's not taking some extra space as well. Okay, now what I can do, I am simply going to do some cleaning on that. Okay, so what I can do, we simply going to taking the selling value of that, not the floor value. If I taking the floor value of that, it should be the zero. So zero is not be here, it cannot be zero because it's already some having some dash. So we can making it, let's say 1 year. So we can use taking the sale value for that. Let's say np dot sell, selling by, तुम तो जानते हो ना. I think that you are coming from, you know about the data structure algorithms and also the uh, some problem statement, just like the how the sale work, how the flow work. Okay, okay. And after that, I'm going to copy it out. For I need to do the same thing for the test df as well, because in my test df it also have the age column except the stroke column because these are test data. Okay, Then we have the test df. Well, now let's try to checking for the gender one. Let's say df, and then we have the gender dot value count. Let's say value count. Okay, value counts, and let's check in here. We have in the female, and then we have the male, and we have the others. So we can remove this other because it's not necessary at all. So let's try to remove it out, but that's better. You can take some shell. Okay, so let's say train df, then we're going to drop it out. Which one? Let's say train df. If the gender is okay, train df, and inside our train df, if the gender is equal to others. That's other. Okay, it could be other. Then after that, we simply going to taking the index of that, and we simply going to implicitly true, so that it not taking the extra spaces as well. Okay, so you can copy this out, and we're going to paste it here, and then we can making it, let's say, test df, and it should be the test df and that test df as well. So, okay, all is fine, test df. And now let's do shift enter. Okay, okay, that's it, nothing but the data cleaning. Quite simple, not so much tough. Okay, so now what I can do is simply going to do the exploratory data analysis. Let's say exploratory data analysis. Okay, let's try to do it out, the exploratory data analysis. So first what I can do, I am going to importing here all of the library which is required for this exploratory data analysis, also called the EDA. Let's call EDA. Let's try to first importing here the matplotlib and the seaborn as well. Okay, let's importing here the matplotlib dot pyplot as plt. Then I'm going to importing here the seaborn as sns. And then I'm going to also importing here another visualization library called plotly dot express and spx, and also import plotly dot graph objects as go, so that you can visualize some graph of that. And then I'm going to importing here the plotly dot subplot, so that we can visualize some subplots. You can also using here the matplotlib to visualize the subplots as well. Okay, then I'm going to setting here the uh, style of that. Let's say dark style. Okay, so let's say dark grid. Let's say dark grid. Okay, so all of our EDA library is added here. Okay, now what I can do, I am simply going to do some color. Let's say float color. I just save it out as a variable. So let's say hashtag 008080, as well as the black. And also I'm going to setting here the palette, so that it can be automatically set to the palette. It should be the palette, and then I'm giving some color. Okay, so I can copy this out and I can paste it here. Okay, so it's at the color as well. Now what I can do, I am simply going to first filter data for stroke and non-stroke. Okay, I'm going to filtering the data for the stroke and the non-stroke, and after that we're going to doing here the univariate analysis for the single types of columns, right? So let's say no stroke data is equal to is coming from train df, and inside our train df we having the column called the stroke. Okay, that's mean if it is equal to 0, that's mean the person is no don't have any stroke. Okay, and if it is equal to 1, that's when the person having the stroke, right? So it should be the stroke data. Now let's try to do the univariate analysis of your data. Let's say univariate It can be called univariate analysis. Okay, univariate analysis, like that. Okay, analysis. Okay, is univariate analysis nothing actually called for analysis for the single columns, right? Now what I can do is simply going to analysis for the stroke column. So let's say first counting it out. Let's say stroke count is equal to, we can counting out, let's say train df, and inside a train df we can using here stroke dot value count. Let's say value counts. Okay, this is how you can actually counting here the stroke count. Okay, so let's try to print it out and see that how it actually work. Yeah, we can see that we having zeroth number is nothing but 14671, and 1 is nothing but 632, which one is quite like imbalanced data set. Okay, just like the credit card. Okay, we got some problem on here. Yeah, we need to also handling this out, this imbalanced data set in our stock data. Now what I can do, I am simply going to first uh, draw on plot and try to checking this out, uh, how it actually look like. Okay, in a pie chart, let's try to checking this how many percentages are here. Okay, so I can using here the px.py plot, and inside that I can giving here my stroke count because I already counting out. Let's call it stroke count, and in the values I can give it here the stroke counts dot values, and inside our name, so what we have inside our names, it could be names, we have the no and the yes, right? So it could be no and it can be yes. Okay, fine. And after that, into giving one title, so let's say give one title, let's say uh, proportion okay, proportion of stock cases, like that. Okay, and after that I need to also giving here one more thing. Is nothing but, okay, let's try to format it out. It's nothing but our color discrete sequence. Okay, so what I can do, you can using here the plot color that you actually already added here. Yeah, then after that we need to update our figure. So let's say figure, so let's try to define into a variable called figure, and then you can say the figure dot update update layout. Okay, so let's update layout, and inside that I can giving here my legend legend title text. Okay, legend title text is equal to stroke status. Let's say stroke status. Okay, then we can giving here the title x, let's say 0.3 is pre-computations is already pre-computed. Okay, and let's say 0.95. Okay, and after that we can using here pick dot show figure dot show, we can giving here the format, let's say svg. Okay, so it'll taking times, not so times actually. Then you can see the proportions of the stock cases, and you can see just 4.3% is nothing but having the yes, and 95.9% is nothing but the no. Okay, this is how it will look like. You can see the pie chart as well. Now let's try to do the bivariate analysis of that. Okay, let's try to do the bivariate analysis. Okay, so let's say bivariate analysis. So see, univariate analysis is nothing but is working on just one single classes. It can be the target columns. Okay, it can be the target columns. So for the bivariate, you need to giving here two. It will actually working on two more columns. Okay, so for that you need to actually define here on functions. It's nothing but the custom histogram. So let's try to make it out. Let's call custom histogram. Here you're going to taking here the columns. It's nothing but the string, and also we're taking the titles. It's nothing but one kind of list. Okay, and after that we're simply going to calling our go figure. Okay, so first what I can do is simply going to creating here one bar plot for the bivariate analysis. Okay, and also we're going to plotting the columns. Okay, and this title is nothing but taking the list of the plot in the x-axis. Okay, So let's try to first making here one subplot. Then inside a subplot, we simply going to actually set one by one. So let's say sp dot make subplots. Okay, make subplots. It should be the subplots, and inside the subplots we can giving here row number. Let's say row 1, and column should be the 2. So it should be the columns equal to 2. Should be the rows, right? Rows equal to 1 and column should be equal to 2. And after that you can giving here the subplot titles is equal to, first one is called the no stroke, and we have the yes stroke. Let's say no stroke, and then you can giving here the yes stroke, right? Yes stroke. Oh, fine. Now that's our figure. So inside our figure, what I can do, we simply going to plotting here uh, the histogram. Okay, because this is the bibrate analysis, so that means it having the two plot, right? So one is a no stroke and another one is a stroke. Okay, so let's say histogram of the no stroke data. Let's say no stroke data. So we can using here the px dot histogram. We can using the tab key from here and histogram, and then we need to giving here no stroke data, and as well as you need to giving here columns. Okay, so let's say column is fortunately coming from the parameters, and also you need to giving here the color discrete sequence. We can giving here a single color. So let's giving here hashtag 00 uh, 8080. Okay, this color. And after that we need to do the same thing for the stroke as well. So we can copy this out and we can simply going to paste it here, and instead of the no stroke, let's making it stroke, and it should be the stroke data. Okay, it should be the stroke data. Okay, stroke data, this one. Okay, and inside the x1 we have the column as well. Okay, now let's try to add it inside our figure. So let's try to add figure dot add track, and inside our track we're going to adding here our histogram no stroke. Inside that we're having one column called data, and we're taking the first index for that. While actually creating the histogram, it having a data column using, when you have to do it using a floatly. Okay, and inside that you're going to show it for the row number 1 and the column number 1. So same thing for the stroke data, we need to show it inside our column number 2, because we already mentioned here the columns is nothing but 2. So it should be the stroke histogram stroke, and inside that we need to using here column number 2. And then after that what I can do is simply going to update our layout. So let's say fig dot update layout, and inside that we can simply going to giving the title. So let's say title is nothing but coming from our parameters, so we can taking the first of that, and inside the title x we can giving here let's say 0.5, and also you need to do the same thing for 2 1. Okay, let's say enter, and instead of the layout we need to giving here the x-axis and the y-axis. Let's say x-axis. Okay, x-axis and title text. Okay, it should be the title text is nothing but the titles of 1. Okay, we don't need to giving here this one. We can removing this thing from here, and after that it should be titles count. Okay, title text is nothing but title count. Let's say title text is nothing but the title count. We can removing this one. It can be the count, and it should be the y-axis. Okay, it should be the y-axis. Cool. And after that we simply going to return here our figure. So let's say return the figure. So what we actually do here, we just creating here a method that's called the custom histogram, which one creating here the custom histogram, which one taking one columns, and as well as it taking some titles, and based on the titles it will try to creating one subplot, and inside the subplot it will printing here that based on the target column how many feature having the stroke and how many feature having the non-stroke. So let's try to do it for the average glucose level, because if I see this one, we're having some unique value. Okay, unique value on that. So just like more unique values we can working on this one. Okay, so let's try to copy this out, and after that I can go on here and call in this custom histogram. Okay, histogram, Is it running? Yeah, it's not running yet. That's why it's not showing up. Custom histogram, and inside that I can giving here this average glucose level, and then inside that I can giving some list. Let's say average glucose. It's nothing but the title, right? Label, label distribution. Let's say distribution by stroke. And after that we can giving here average glucose level. So let's say average glucose level. Okay, that's it. And after that what I can do is simply going to store it inside one our figure. And after that we can show it out. Let's say figure, and then here we go, we can using a fig dot show in the form of svg. Let's try to check this out, any error or not. Okay, custom histogram is not defined. If copy this one, and then let's try to call it out. Okay, sp is not defined. Okay, his one is sp. Okay, subplot should be not p, it should be the sp. That's why. Okay, anything error? Columns is not defined. Okay, column is not defined, it should be the columns. Okay, it should be the columns, it could be the columns. Okay, now let's check it again. Okay, fine. Now you can see here, yes, stock. Okay, you need to also changing here the color of the lights. Let's say black colors. Okay, yeah, now it's look cool. But if you see that the ES data and the non-stock data and the stock data, it don't have any significant changes on the average glucose level. You can't actually interfere the people with the high glucose average and more prone to stroke due to some observation of the data. Right tail and the second part, you can see in the tail part it's just having some yes, in having some yes, but the portion of the 100 is almost the same. So you can actually taking this average glucose level as nothing but for the prone to a stroke, right? So a similar category of the high glucose, the first plot are not actually stroke positive. We can see that. So what I can do, we're simply going to export mode for the age. So let's try to copy this out, and I'm going to pass it here, and let's try to making it for the age. Let's check in this sort if age is actually compatible for that. Okay, so we can making it, let's say age distribution by stroke. Okay, by stroke. And after that let's making it just simple age. Okay, and then you can see that this is based on the age. I didn't get any significant value on here. Yes, for the years stroke, when the age is more higher, the possibility of the stroke is increases. You can see that. For the no stroke, you can see here, uh, it can be any kind of ages, but for the stroke after the 14, it should be increases. The percentage of the stroke is actually increases. We can say like that. Yeah, is having some uh, issue on that. Just having some relations, correlations on that. It's just having some pattern on that. Let's try to do it for the BMI. Let's try to do it for the BMI. Okay, I don't need to think the for the BMI. Let's say for the body mass index, we can plot some Boolean plot as well. We can checking here which kind of range is affected for the BMI. If I using here, let's say if I using here the BMI, if I using here the BMI, and you can see here you can get any significant value from here. Okay, you can get any significant value from here because all the plot are mostly same. So what I need to do, if I going to plot one Boolean plot, I can see that in the which BMI, in the range of which BMI the stroke may be happen. Okay, so what I can do, I am going to actually taking the, let's start checking the stroke of the mean. So let's stroke data, and we have the BMI, and we're taking the mean of that. Okay, if it's checking the mean of that, it's nothing but 30. Okay, 30 is the mean for the Bayesian plot. For the 30, it having some if the BMI is nothing but 13, it having some possibilities of a stroke. Okay, Now let's checking for the non-stroke data. Non-stroke. Okay. You can also calculate your BMI. You know how to calculate the BMI, body mass index. Okay. So 28 is nothing but the no stroke data is nothing but the median value for that. Now let's try to plot one Boolean plot and try to figure it out. Okay. So we can uh, make it more clear. Okay. Let's figure. You go to px dot Boolean, and inside the Boolean plot I need to giving here my full data set, trend df, and inside our y we need to giving here the BMI, and the x we can giving here our target column, that's called stroke, and inside that I need to giving some information regarding our Boolean plot. Let's say box should be the true, and our width and the height, let's say giving here the 700 is predefined, and height let's say 500, and let's giving here some color discrete sequence, let's giving here a plot color that we actually use it here. Then we're going to giving here one title, let's giving here the title, okay, not title, actually title is equal to nothing but BMI and stroke status. Okay, and then we can giving here the labels. So labels is nothing but if from the stroke we having the stroke status, stroke status, and then for the BMI we having making it called BMI. Okay, and now let's try to figure it out, our updated layout. So let's say fig dot update layout. Okay, that's a title x equal to, it's really an advanced project because we already just go through each of the columns and try to explore it more. So yes, you can use it for the your final year project as well, because it's really important here, you know, to also handling it here for the data imbalance, and also we do some plotting on that which one is impactable for the stroke. Okay, you can add it in your thesis paper as well. Okay, so let's try to run it out, and you can see that for the non-stroke we can see that the value is nothing but around to 29. Okay, we can see that for the stroke data it's nothing but it's around to 28, and for the stroke data you can see that the mean, or you can say median, is nothing but the 30, but the low and the high is nothing but seems like it's proportion of the 27 to 30. Okay, 27 to 33, the proportion of that, that's mean both classes it seems to roughly the same mean of 29, we can say like that. And also a fairly large proportion of the people who have a stroke is positive, having the BMI around the 27 to 33. We can say that if the BMI is nothing but 27 to 33, we can say that it may be possible of having the stroke. Yeah, it's having the possibility of stroke. Let's try to also do more analysis on the smoking status, because smoking is more impactable for the stroke. Okay, brain stroke. Okay, so let's try to checking for the smoking status. Let's try to taking some value from that. So let's say smoking smoking status, and also let's taking, okay, let's, it's better we can taking one shell, and we can say that let's train df dot columns. So we can taking the hypertension, we can take in the heart disease, we can taking the, okay, let's taking this one, and taking this one heart disease, then you can take in this residence type, just taking the counting on that. Okay, if I go on here, then you can see here the hypertension, heart disease, average glucose level, BMI, stroke. Okay, and we can adding some of them. So Xander, you can take in the Xander from here, and then let's spit it out, and just for the counting purpose, and also Ivermectin. Okay, BMI is not needed because you already explored it out in the 27 to 30, not actually having the possibility of the stroke. Okay, let's try to figure it out. Let's figure, and the axis is nothing but, let's say plt dot subplots. Okay, and inside the number of rows, it can be the 3, and number of columns it can be the 2, and then let's give it the figure size is nothing but let's say 12f comma 10. Okay, now let's try to look through all the value. Let's say axis and the x values, x value in zip of our axis dot flat, and also giving here our x values. Okay, show me the x values. Okay, nothing more this one. Let's say x values. Okay, and after that what I can do is simply going to do the count plot. Let's say sns dot count plot, and inside that I can pass in my data. So let's say data is nothing but my train df, and then x is nothing but my x underscore value, not values here because it's coming here one by one, and here we can giving here the stroke, and then axis is nothing but my axis. Then now I can set one title. So set title, we can giving here one f string, and inside that you can giving here the x values, x value dot capitalize. You can making it capitalize or you can lower. Okay, copy. Okay, let's make it x values. Is it coming? Capitalize. Yeah, capital is coming up here. Okay, then after that you can making it, let's say, and smoking status. Okay, and after that you can simply go and adjust the layout. So let's say plt dot tight layout, and after that we can simply going to show it out. Importing here the matplotlib, but we don't use it, how it can be happen. Okay, so that's why let's import it here. Okay, and we can see that smoking status and the smoking status, the hypertensions, it having for the zeroth, you can see here it having the hypertension is nothing but bigger than in the zeroth. And for here you can see that the residence type, it can be urban, it can be rural area, and also the heart disease, the smoking status quite low because it just having some lower amount of data. Okay, so now let's try to do the data preparations and the pre-processing because we already do some more analysis on the data. So now let's go on the data preparation and the pre-processing. Okay, pre-processing. Let's try to do this out and try to importing here important library for the data preparation and the pre-processing. Okay, so let's import here. Let's say from sklearn dot pre-processing, we are going to importing here the one hot encoding and also the ordinal encoding. Okay, we're simply going to creating here one pipeline. So why this one hot encoding actually? Because we're having some categorical value as well. So we need to also handling these ones. Okay, using one hot encoding, it's nothing but called the categorical value to the numerical value transformations. And after that, we need to also importing here from sklearn dot pipeline. We're actually importing the pipeline because we're going to creating here a pipeline of the each of the encoder, right? So we're going to import, let's say, pipeline, and then from sklearn dot compose, we're going to importing here the column transformer as well. So it's a column transformer. Okay, and after that from sklearn, I am going to importing here the set config, and then I'm going to giving here on configurations. Let's say set config and configuration. Let's say display equal to diagram. So let's say display equal to, let's say, diagram. Okay. In the next tutorial, we're actually trying to implement one linear regressions and the logistic regression model from the squares without using this sklearn library. Okay, just from the raw, we're going to making here the all of the component just like the MSC or the y equal to mx plus c for the linear regression in from the squares as well as the coefficient whatever. Okay. Okay. Now what I can do? Let's checking for. Okay, let's taking some shell first. Okay, let's taking all of the columns. Let's say train df dot columns. So we have this kind of column, right? So let's try to actually extracting here the dependent and the independent features. I mean, which one is the target column and which one is input column. So let's say we're creating a variable called input columns is nothing but from train df, and inside our train df dot columns, we take except the last column, we're taking all of the columns, and we're simply going to making one list of that. Okay, then after that, what I can do is simply creating one list of that, and from the one to rest of them. Okay, except the last column, we're taking from all of the columns. Okay, except the id. Then after that, we can simply go into hit enter, and we're also giving it the target column. So let's say target call is equal to stroke. Okay, that's means except the id column, we're simply taking from the gender to a smoking status, and then taking here the stroke as a target column. Okay, if we're checking this one, you can see, let's say input calls. Then you can see here gender, age, hypertension, heart disease, if you are married, work type, residence type, average glucose, BMI, and the smoking status. Okay, cool. Now what I can do, I am simply going to taking one copy for that. So let's say train inputs, because we're going to passing it out. So let's say train inputs equal to, let's say train df, and inside that taking one copy for our input columns. So let's taking one copy for the train inputs, and then to having the train target, and we have the test input. So it should be the train target. Okay, target, and it should be the target columns. Okay, it should be the target column. Just taking one copy for that. Okay, and then it should be the test input. It should be the test input. Okay, and it's also be the test df. Okay, it should be the test df, because we have the train and the test data set as well. Okay, let's shift enter, and now let's try to encode the categorical columns. Okay, so we having some kind of categorical column, which one is data type is nothing but the objects. Let's try to handling this out first. Okay, so let's train inputs, and inside this input, let's select the data type. Okay, let's select the data types, which one is include the np dot number, which one is nothing but the np dot number. We simply going to taking the list for that columns dot to list. So what is this? This is nothing but for the numerical columns. That's a numerical columns, and numerical columns is nothing but our age, hypertension, heart disease, average glucose level, the BMI is nothing but our numerical column. So except this, all of them columns is nothing but our categorical column. That's mean if it is not the np dot number, or if it is an objects, if it is an object, that you can say that this is nothing but our categorical columns. Okay, it should be our categorical columns. Okay, so if I try to checking this one, this categorical columns, then you can see that gender, the even merit, work type, residence type, specification status is nothing but the categorical columns. So now what I can do from the categorical column, let's try to removing here. Let's try to removing here the smoking status. Okay, let's try to remove it out from the categorical columns. Now we're simply going to making it the ordinal encoding for this one. Why? Because it having so many values. If I stacking this one, just to white, I try to make you comfortable and make you understandable. If I see the gender, so let's say gender, you can see it having male and the female. Let's say unique. Okay, unique. Okay, let's try to not like that. Let's try to making it like this. Let's say n unique. Okay, n unique, and we already checking this out before, like. So inside that, you can see that inside of a Xander, we having just 2. Okay, but the smoking status is having the 4. Okay, so what you can do is simply going to apply here the ordinal encoding on that. Okay, let's try to do the ordinal encoding inside our smoking status. Let's say ordinal encoding, and inside there, let's take him shell more, and in this, let's try to first checking here the train df of smoking status of unique. And we can see that we have never smoked, the formerly scoped, unknown, and the smoked, right? So inside that, what you can do, you can giving some categories inside on double list. So which one is nothing but, let's say, unknown. First we have the unknown. Okay. Okay, we can removing this one, right? Then what we have the never smoked and the formerly smoked and the smoked. Okay, we can copy this out from here and you can paste it here, and after that you can smoke. Just I'm going to following here the strategy, right? That's been unknown, which is not known, never smoke, formerly smoke, and smoked. थोड़ा थोड़ा करते नहीं करते इसके बाद. Okay, so this is nothing but for the ordinal encoding. So let's say ordinal encode. Okay, let's hit enter. Now let's try to do the one hot encoding also. Let's try to creating one uh, instance for that, and inside this I'm going to making here handle unknown equal to ignore. Okay, then let's try to making it one hot encode. Let's say it should be the one hot. Okay, it should be the one hot encode like that. Okay, now what I can do is simply going to creating here one column transformer, and inside that inside that I'm going to passing here our ordinal encode. So let's say ordinal encode, and as well as I'm going to give it here the ordinal code, just passing here ordinal code, and inside that I'm going to giving here the status of the smoking. Okay, so it should be smoking status. Okay, and then I am simply do the same process for the one hot encoding. So I am going to copy this one, and after that, instead of the ordinal encoding, I'm going to making here the one hot encoding, and I'm going to making this one is called one hot encode, and instance of is test. Okay, using here the categorical column. Okay, accept that. Okay, categorical columns. Okay, take two position encoded, but 3 was given, having some problem on that. Okay, it's taking. Okay, we need to giving it out inside one list. That's why this kind of problem. And let's try to define into a variable called preprocessor. Okay, now it's taking fine. Now let's try to import it. Let's try to actually apply it inside our full data set. Let's fit with our train inputs, not train df, because we are taking the copy for the train inputs as well. Now you can see here it will creating here the column transformer, and inside the column transformer we simply going to taking the ordinal encode and the one hot encoding. If you don't know what is the ordinal encoding, you can also go on Google and search for that. Now let's try to taking the features of the preprocessor. Let's say preprocessor dot get features name out, and let's try to taking one list of that. Either पे आ जाओ बेटा, then list of that, and then I'm going to making it called encoded columns. Okay, and if I try to checking this one, this encoded column, now you can see here how many encoded column it have. It have in the ordinal encode, the gender female, so gender male, either merit no, like that. Which one is apply on the 100 encoding, and except the smoking status, all of the column is applying here the one hot encoding. Now we already fit in this out, right? Fit without. Now let's try to transform this out as well. Let's say preprocessor dot transform, and inside that we're giving here our train inputs, because it to fit and also transform our data, right? Let's try to making it, let's say train inputs, and inside that we're passing here our encoded columns. Okay, encoded column, so that it can fit with our actual data set. Let's try to copy this out, and after that I'm going to making it call test inputs. Okay, inputs, encoded column, and copy this out, and I'm gonna paste it here. Cool. Anything error? It should be the encoded calls. It could be encoded calls. Okay, fine. Now let's try to divide our data set for the X train and the Y train. Okay, let's say X train is train inputs of the numerical column because you are taking out, and plus the encoded column, not categorical because you already making it in the numerical format. Let's try to copy this out. बच्चे इसके बाद दो बार कर दो. Which one is nothing but for the white train, and it should be our trend df. It should be our trend df because we don't apply here the uh, apply. We can apply it in the train inputs because in our train inputs we don't have the target column, so it can be the target columns. It can be the target columns. It can be the target columns. Okay, and then in the X test, it can be the train inputs or test input. It should be the test inputs. Okay, this one fine. Now shift enter. Okay, now if I try to checking here the X train dot head, we can check in this one, and also you can check in this one if the X train and the X train size it should be equal. Okay, make sure that your X train shape and the X test shape should be equal. Let's start checking this one. Let's X train dot shape of the one is equal to X test of the shape is equal to 1. Yeah, it's true. That's when we can go on that and you don't get any error. Cool. Now let's start to split our data set into train, test, and split. Because we already have the task data, so it can be the validation. So let's say split data set into training, and validation set. Validation set. Okay. So for that, I'm going to importing here from sklearn dot model selections. I'm going to importing here the train, test, and split. Okay, it should be train, test, and split. Okay, it should be coming up here. Okay, you can removing the space from here. It's not needed at all. Now I am simply going to call it out. Let's say train, test, split. Inside that, I'm going to passing here our X train data and our Y train data, and then our test size should be the 0.2, and let's giving here the random state, let's say 42, and it should be the our X train and the X validation and the Y train and the Y validation. Fine. Now let's try to run it out, and you can checking the shape of that. So let's try checking the shape of that, and you can see the how the shape is look like. Okay, now what I can do, we're simply going to creating our baseline model. Let's try to getting here our baseline model. Okay, let's try to creating here and try to importing here all the important module. Let's import from sklearn dot linear model. We have the logistic regression, right? Then from sklearn dot tree, we're going to be importing here the decision tree classifier. Then from sklearn dot ensemble, we are going to importing here the random forest classifier. It should be R should be capital, random forest classifier. Then from light ZBM, we're going to importing here the L ZBM classifier. Okay, then from exiboost, we're going to importing here the XGB classifier. Then from the IMB learn, so let's say from IMB learn dot oversampling, I am going to importing here the smooth. So why actually smooth and why oversampling? Because if I see that our data shape is nothing but 1 2 2 4 2, if I checking the shape of the, if I checking this one, let's try to go up, and if I checking this one, you can see in the graph it having lower number of stroke data. It's nothing but 62. That's mean we need to do the oversampling. That's mean we we need to increasing our stroke. Okay, you need to increasing that stroke. You can also do the undersampling, but in the undersampling, many kind of data can be lost. Many of the data should be lost because it is removing all of the column and try to making it 632, which one is inconvenient. We can actually using the oversampling. If you want to know more about the imbalance data set, I mean how to handle the imbalance data set, you can follow the credit card fraud directions. Okay, it's already available in this series because we are following one strategy and try to solving one problem based on our previous projects. Okay, previous projects. So yeah, now what I can do, I am simply going to also importing here some kind of matrix. So let's say from sklearn dot matrix. I actually choosing this kind of project which is having some problem. Okay, that's why I actually creating this series, multiverse series. Okay, already 44 projects are already uploaded. You can follow along. Okay, and let's say accuracy score. Then you have the precision score. It's actually making you actually see more clear that yeah, this guy is actually working on so many projects. He's having some experience on the data. Okay, so recall score. Then also on F1 score. Okay, let's import it now. And also let's try to initialize our models. So let's say models. Inside of that, we can taking the logistic regressions. So let's say logistic regressions. And then what I can do, we can giving the name of that. Let's say logistic regressions. And then we're taking one comma, and inside there let's taking the random forest classifier, and then let's taking it out, and let's copy this out, and I'm going to paste it here. And after that let's taking another one. Let's take xzb classifier. Okay, and then I'm going to give it here this xzb classifier. And then after that I'm going to taking here the light. It's called the lgb classifier. Okay, it should be the lgb classifier. And let's try to making it cost, let's say light. It should be the, it's nothing with the light gbm. Okay, so taking this fourth one, you can take in the decision classifier, this xzb classifier, already taking this out. A smooth will be applied. Okay, don't worry on that. You can take in this decision classifier as well, but it's taking time. That's why removing you. Okay, so now let's try to shift enter. And let's say define a function which one actually help us to evaluate our model, because we already importing here all of the things, all of the matrices, just like the confusion matrix and the accuracy matrix. So we can simply go to define here and functions, and after that we can actually store it this confusion matrix inside and list. So let's say taking the model, which are taking the model, and it will taking the x train and the y train and the x validations and the y validations. So what it can do, it can just taking the y predictions, and after that we're simply going to predict it out. Let's predict. That's mean just how you call in this evaluate model functions. It will give me the confusion matrix. It give me the accuracy score. It give me the recall score, F1 score, and all of the things. Okay. So let's say X validation data, and now let's try to do that. Let's say confusion matrix, and inside that I can giving here Y bell and the Y predictions, Y underscore predictions. Okay. It should be the confusion matrix. Let's say confusion matrix like this. And then what you have, we have the accuracy score, and inside that you can same passing here the y bell and the y predictions, and it should be the accuracy. It should be the accuracy, and after that we have the precision. Let's say precision, it should be the precision score. It should be the precision score, and inside that we can giving here the y bell and the y predictions. That's our precision value, and we have the recall. So let's say the recall score, and inside that we can giving here same thing, y val and the y predictions, and recall is done. And now we have the f1 score. It could be the f1 is equal to, let's say, f1 score, and inside that we can passing here the y val and the y predictions. Fine. Now let's try to return it here. Let's say try to return here the confusion matrix. Let's say confusion matrix, and then we have the accuracy, we have the precision, we have the recall, and then we have the F1. Okay, so that's our evaluate model. Now let's try to um, creating another method which will help us to uh, giving here our matrix in the form of the data frame. So let's say matrix df. So let's say matrix df, and inside that I can passing here the model and the model name. Okay, and then I can calling my evaluate model, and after that I can taking this one for the model and the x train, the y train, and the x bell and the y bell, and it will give me one confusion matrix, and rest of them I'm going to add it inside one data frame. So let's making it a star. I mean rest of them I'm going to save it inside one df. Okay, now I am simply going to uh, add our confusion matrix inside one dictionary. Let's say confusion matrix. Okay, mats. Okay, I am simply going to copy this out, and inside the confusion matrices I am going to passing my model name so that I can show it out. Let's say confusion matrix, and then inside our df I'm going to passing here my df. Okay, and then I have the model matrix, and inside the model matrix I'm going to creating one data frame so that I can see in a data frame format. So data frame I'm going to passing here data is equal to df, and then inside that columns I having uh, the accuracy. You can see accuracy, precision, recall, and reference code. Let's say accuracy, and we have the precision and the recall. If you don't know about that, what is the accuracy, what is the reference code, you can go on the Google and search for that. What is the accuracy, what is true positive, what is true negative, and how can you calculate the accuracy and the precision from the confusion matrix. And then I'm simply going to insert it. Let's say model matrices dot insert, and inserting here the model name as well. So that's a model, and as well as I'm going to passing here the model name. Okay, so let's say model name, and then I'm going to return here our model matrix. This one. Okay, now I can actually calling it for each of the model. So let's say for model, okay, I need to also giving here a verbose is equal to 1 so that I can see the progress of that. So let's say model, and we have the model name. So we have the model name in models, because in our models dictionary we have the model and the model names. So let's fit it out. Let's the model dot fit, and inside that we need to passing here our x train and the y train data. Okay, x train and the y train data, and then we simply going to calling this model matrix is equal to matrix df, and inside that I can passing here the model and the model name. Okay, and then let's try to define here one list where we can actually store our predictions. So we can simply go into store it, append, and inside that I can giving here the model matrix. Okay, now see that what kind of accuracy you can got. Okay, you can see verbose for the light GBM. Okay, how many score it actually get. You can actually showing here the predictions. You can see that how the accuracy of that is actually working. Model, the accuracy, precision, recall is actually working on here. Okay, model, accuracy, precision, recall. If I using here the hat, it is working because it's not a data frame. I think so. Yeah, it's not working because it's not a data set. Okay, or main data frame. Okay. Okay, let's enter because it's not working because it's nothing but on list. We actually add it inside on list, right? So what I can do now, we already actually using here the machine learning model, just like the loss regressions, the random forest, and the XGB and the light GBM, but we don't apply here the oversampling yet. So let's try to using here the oversampling. Okay, so for that I'm going to taking some shell, and I'm going to creating one instance of that. Let's try to taking here oversample, and then I'm going to creating the instance of that, and after that I'm going to apply it for the x train x train dot let's say ns and the y train ns, because I'm going to apply it, right? And let's say oversample dot fit resample, resampling it, let's, and in our x train and the y train data. Now it actually oversampling our data set. If I checking this one, the shape of that, you can see here shape is increases. If I go up, and if you're checking this x-trend shape, you can see here, this is the x-trend shape. It's nothing but 1 2 2 4 2. Now this is nothing but the double of that, double of that. Okay, so that's mean actually increasing your features. Okay, increasing your features using the uber sampling. Uber sample, that's mean taking the taking all of the value from the stroke and try to creating here the same number of values for the target column. Okay, same for the stroke, same for the not stroke. Okay, now let's try to apply it for the logistic regressions. Okay, so what I can do, we can using here the logistic regressions, and inside that I'm going to creating here an instance of that. Let's say lr with, let's say smooth. You can apply it any kind of machine learning model. I just show you that how the word sampling actually work. And then I'm going to using here lr with smooth dot fit with our x train ns data, let's say x train ns, and as well as the y train ns data. Okay, now let's say lr smooth, and it also have the metrics. Let's say metric data df, and inside that we can passing here our model and with one name. So let's say logistic with smooth. Okay, so this is nothing but my, it will return one value. So let's say lr smooth with a smooth, let's say this is the matrix, let's say mat. Okay, and then I'm going to add it inside my predictions. Let's say predictions dot append, and I'm going to adding here lr with a smooth mat. Okay, now it's added inside our predictions, these predictions. Now what I can do, I am simply going to printing it out. So let's try to printing it out. So what I can do, let's say for model underscore name, and also the confusion matrix, let's say confusion matrix is nothing but in confusion matrix confusion mats dot items. Okay, and inside that we can simply go to printing it out. Let's start printing it out. Let's say f string, and then you can using, say let's say confusion matrix. Okay, matrix for, you can giving here the model name. Let's say model name. Okay, because in our confusion matrix it's nothing but a dictionary, it having the model name and the confusion matrix as well. So we can simply going to printing it out. Let's say print here the confusion mat. It's nothing but the confusion mat. Yeah, confusion mat, I mean this one, and we can give some spaces on that. Okay, now you can see here this is the confusion matrix for the logistic regressions, true positive, true negative, and false positive and the false negative. And you can see here for these cases the smooth is also work better than this one, but for this one is working very fine. Okay, confusion matrix for the logistic regressions. Okay, so this is how you can actually plotting here. Now let's try to do one more thing for voting, so that you can choosing this one. Let's try to do the voting. Let's try to do the voting classifier. Okay, let's say classifier is nothing but the hard and soft. It having two things, and one hard and another one is called soft. Okay, let's try to do it out. And now from sklearn dot ensemble, I am going to actually importing here the voting classifier. Okay, and after that what I can do, I am simply going to creating here one estimator, and inside the estimator I am going to passing here all of the model. Okay, so inside that I can adding, let's say estimator dot append, and inside that I can passing here all of the models. Okay, I'm going to copy this one Yes, I can copy this one, and then I am going to adding this one like this way. Okay, it's logic regressions, and inside that I can, let's say, estimator dot append, and just giving here one things, and I'm gonna copy, paste, paste, and just close it. Okay, so I need to close it from here. uh okay, we need to giving here the first the name, and after that we can giving here the model name, so it should be the opposite of that. Okay, so what I need to do, I need to give one first, let's giving one actually bracket, and after that you can configure this one. Okay, so what I can do, I am simply going to cut this one. I'm going to cut this one, and I'm going to pass it here. Okay, and after that I'm going to cut this one. Okay, I need to remove the space from here, and then I'm going to pass it here. Okay, and also I'm going to cut these sections, and I'm going to pass it here, and same thing for this LGB classifier. Okay, LGB classifier, and after that I can going to add it inside that. Okay, let's take it out. Fine, now that's what estimator is ready. Now we can actually, okay, it having some problem. Okay, I'm going to removing this one as well, otherwise I can got some problem, unexpected intent. Okay, now let's try to first apply here the voting herd. Okay, so for that, what I can do, you can using here, let's say, vote classifier, creating an instance of that voting classifier, and inside that I can giving here the estimator, and our estimator is nothing but our estimator that actually created. And after that, for the voting, we're going to apply here the hard voting. So let's say hard, and this is nothing but a BC herd. So let's say BC, let's say herd. Okay, and after that I'm simply going to fit it out. Okay, let's say fit it out, and let's take in some shell, and the fit with our train and the test data. So let's have train. Okay, x should be x train, and we have the y train data. And after that I am simply going to creating the matrix of that actually created matrix df, and we have the BC of the herd, and then we need to giving one name, it's called the BC underscore herd. Okay, and then it's nothing but the BC, let's making it capital BC herd matrix, let's say mat, and then I'm going to add it inside the prediction so that you can see it later on. Okay, let's say append. This is the best way to do that, just creating one functions for all of the metrics and simply running this out. Okay, so let's say BC herd matrix. Okay, so it will applying it for the voting herd. Now you can see here. Now let's try to apply it for the voting soft. So let's try to adding it out, but before that let's try to checking here our voting herd matrices. Okay, let's try to checking this one. Yeah, you can see the accuracy is nothing but 95% accuracy, quite good, and precision is 0.5. Okay, let's try to apply it for the soft as well. So let's, instead of hard, we can making it soft. Okay, so I'm going to copy this one, and I'm going to making it soft. This should be the soft, this should be the soft, and it should be the soft, it should be the soft, as well as it should be the soft. Okay, okay, bc soft, bc soft, bc soft. Okay, let's try to shift enter, and now let's checking for the soft matrix as well. And for the soft we got here 95, same types of accuracy got here for the soft as well, but yeah, for the soft we got some 0.23 is better than the hard. Okay, now what I can do, I am simply going to do the performance comparisons using the confusion matrix, AUC, and the ROC curve, and also the precision and the recall. So what I can do, I am simply going to do the concatenation of the, let's say, concat of the predictions. So let's say predictions, and I'm going to making the ignore index should be the ignore. Let's making it true, and also let's start to making it short. Let's making it false right now. and this is nothing but my prediction base. So let's say prediction base, and after that, based on this prediction base, I'm going to short it out. That's a short, and let's short by values, prediction base and short by values, and inside that I'm going to short it based on the recall score. Okay, that's a recall because accuracy is mostly similar, so recall score can be the best to us. Okay, and then inside that I'm going to making this ascending. Okay, it could be ascending. Okay, ascending uh should be the false. Okay, ascending should be the false. Okay, and it's by the recall, it can be here, and ascending should be the false. And after that I'm going to giving some style, and I'm going to making this height. That's axis is equal to, not axos, axis is equal to index. Okay, that's it, and that's our prediction base. We can copy this out, and let's try to shift enter and try to checking this one. Okay, now you can see here how it look like. So logistic with the smooth is having the best recall score, but having the low accuracy is nothing but the 78%. And for the PC Heart is nothing but the highest accuracy, but having the lowest recall score. You can do it based on the accuracy as well. So let's say accuracy. Any problem? Okay, I think let's try to making it recall. Let's say try to copy this out. Let's try to do this out based on the accuracy. Then you can see here for the accuracy, BC Heart it having the more kind of accuracy. Okay, but recall score is so low, and the precision is 0.5%. Okay, so let's taking it out based on the recall. Accuracy good is not mean the model is good. Okay, so prediction base. Now let's try to actually plotting here our confusion matrix as well. So let's say models to plot. Let's say models to plot. So which one is nothing but that you actually add it here is the logistic regressions. So we can, okay, we can copy this out from here, and we can copy this out. No, we can't copy this out. We need to actually use it here. So let's say logistic regressions. Then we need to have the random forest. Then we have the XGB classifier. We have the XGB classifier. Okay, we can copy from here. And then we have the XGB classifier. Which one is this one? And then we can do all of them. And then let's try to do it for the logistic with smooth. Okay, so let's start plotting this out. You can plot all of them. So I am simply going to actually creating here one plot. So let's taking one subplot. So let's say figure, and the axis is, let's say plt dot subplot, and inside the number of rows should be the 2, and number of columns should be the 2, and our fixed size is nothing but, let's say 9,7. And after that let's try to creating it based on the our models to be plotted, because we already input it out. So for in zip it's nothing but axis. It's our axis. So this axis is nothing but coming from here. It should be our axis and our model name. Okay, in axis, this axis, and we're simply going to making it rabel. And after that you can giving here models to be plotted. It should be models to plot, and inside that I am going to actually calling here our confusion matrix. So that's our confusion mat, confusion mats, and inside that I can passing here the model name, and which one giving one confusion matrix. Let's say confusion matrix. And after that I can show one heat map. So let's say sns dot heat map, and inside the heat map I'm going to passing here the confusion matrix, this confusion matrix. And after that I can giving here the annotations equal to true. Okay, and also I'm going to giving here the fmt, let's say give it here the d, and also I'm going to giving here the cmap is equal to, let's say giving here the blows. And after that I can giving here the axis is nothing but axis, and then I can giving some title on that. And then let's say x dot set title, and inside that I can giving one f string, and I can giving here the model name. Okay, and after that I can using here ax dot set x level. Okay, set underscore x level, and inside that I can giving here the predicted and actual. So we can copy this out, and it should be the x level, and it should be the y level, and it should be the actual. Okay, and after that I can go the tight layout. So for that adjusting the layout, so let's say tight layout, it should be tight layout, then plt dot subplot adjust, subplot adjusting the subplots, and let's making it left equal to 0 and right equal to, let's say 0.9, and the top let's say 0.9. It's just like the position absolute, and bottom is nothing but the 0. It's just like that the position absolute in the web designing. Okay, sure. Okay, any problem in valid syntax is called. Okay, and then you can see here some kind of confusion matrix, and you already saw this out, right, in here, but let's show it out in matrix format. You can plot all of them. Okay, now what I can do, I am simply going to uh, actually adding retain and the save the model. You can adding here, you can actually do for the precision recall and the curve, and as well as you can do for the AOC and the ROC curve. It's your homework to do that. Just go on the Google and search for that and research on that. So AOC and the ROC curve is nothing but your homework. Okay, and also nothing but about the precision the recall curve. So precision and the recall curve is nothing but your homework. It's really very simple, just adding here two library. I just add it out so that you don't get any confusion about that. Just using here two library. One is nothing but from sklearn dot matrix, import here the ROC and the accuracy score, and as well as let's using here the ROC curve, and as well as the AOC curve. Okay, this is nothing but for the ROC and the accuracy score and the ROC curve. Just use this one and try to actually plot it out, plot the graph. And for the precision of the recall, let's try to import from sklearn dot matrix. We're going to importing here the precisions. Okay, precision error display. So you can actually use this one and try to actually showing here is the precision the recall scorecard. Okay, so I'm simply going to return and save the model because already this video is getting so many long. So let's say return and save model, and as well as you're going to actually creating here one predictive system. Okay, so now what I can do, I am simply going to do it for actually the submissions as well, because you need to also do the submissions for that. So what I can do, I'm simply going to making, let's say x train is nothing but our train inputs, and if it is train input, we're going to passing here our numerical columns plus encoded columns. Okay, encoded columns, and then what we have the y train is nothing but our train df, and instead of train df we need to passing here our target columns. Okay, and then what we have the predictions. So let's say predictions with based on the LR with smooth data, because this is nothing but one imbalanced data set, predict, and then we have the X test. Okay, then now what I can do, I am simply going to checking this length of the predictions. So that's our predictions. We actually using here the smooth. Why smooth? Because based on the recall score we got in here, the logistic regression is smooth is the best one, but having the low accuracy you can also choosing here the logic regressions or the BC hard whatever based on the accuracy, but it's better you can choosing the recall score because the recall score of the BC hard is so low. Okay, now what I can do, I am simply going to save it inside the sub df. Let's say sub df is nothing but the predictions. Let's say predictions. Now inside of a sub df, all of my prediction is stored. Now what I can do, I'm going to apply it. Let's say pd dot data frame. Okay, data frame, and inside the data frame, I'm going to pass in here my sub df, and I'm going to save it in a CSV file so that I can do the submissions. Okay, I can do the submission in the Kaggle. So that's a submission dot CSV, and I'm going to giving here index equal to none. Okay, let's giving the index equal to none. So need to taking it out inside the same index. Okay. Now what I can do, I am simply going to, okay, it should be submission. Okay. Okay. What is error? Okay, now it's converted the data frame. Now if I try to checking this one, let's say read, I have the CSV, and then if I wanted to checking this one, let's call submission. Submission dot CSV. Then you can see this one. This is the sub df. Let's sub df. Then if I checking this one sub df dot head, then you can see here this is our submission df. Okay, this is how it actually look like. Okay, so you can actually submit it out. You can submit it out. Okay, then you can submit it out inside your Kaggle platform, and you can get some score on that. Okay, now let's try to make the predictions. Now let's try to creating here one prediction system for the single input. So what I can do, let's try to giving one heading. Let's say make prediction prediction on a single input. Okay, so for that what I can do is taking its sub df of stroke is nothing but of our predictions, right? So let's say stroke is nothing but our predictions. Okay, so if I check in this one sub df, then you can see this is the stroke because we already got in the stroke. Okay, now what I can do, I am simply going to taking one dictionary for the single inputs, and after that I'm going to print it out. Okay, let's say single input. Okay, inputs is equal to, let's say first what you have, we have the gender. So let's say first, let's say give it the gender, let's say male, and then what you have, we have the age. So let's say age is nothing but, let's say 33, and then let's say giving the hypertension, let's say hyper. Okay, we can do one more thing. We can taking the train df. Okay, train df dot columns, and we have the hypertension. We can copy this one, this hypertension, then you can give me, say let's say hypertension is nothing but 0. Then we have the heart disease, so copy this heart disease, we can pass it here, heart disease, let's say 0. We don't have any heart disease. Let's say ever merit. Okay, ever merit, let's say yes, but I don't. Then work type, let's say work type, let's say giving the work type, so let's say private. Okay, private, and then after that let's giving the residence type. So let's give it the residence type, let's say giving it here, let's say urban, and then let's using the average locus level. I just add it out from the data set. Let's say 79.53, and after that what you have, we have the BMI. and the smoking status. Let's say BMI. Let's say 31.10. Okay, and then let's using the stroke, not a stroke, smoking status. Let's say formally smoke. Okay, let's say formally smoked. Okay, so that's our single input. Now let's try to save it inside a data frame. So let's say pd dot data frame, and inside let's passing here our single input, and that's our input df. So let's say input df, and after that I'm simply going to use the preprocessor because I need to do the transform our data, and inside our transform we're simply going to passing here our input df, and that's our input df with the encoded column. So let's say encoded columns. Okay, and then we have the x. Okay, so let's say x equal to input df, and inside that I can passing here my numerical columns and with the encoded column because we already encoded this one. Okay, and then what we have the lr with the smooth, and we're simply going to print it out with our x. Okay, and we got here the 0. Okay, now let's try to saving it out our model. Let's try to save it out. You can use here the pickle or joblib. So let's say using here the joblib, and then inside our models you need to saving here 4 things. One is nothing but our encoded columns. So let's say encoded columns. Okay, and as well as we need to add it here, and we need to adding here our numerical columns, numerical. Okay, numeric calls. It should be the numerical calls. It can be the numerical calls, and after that we have the preprocessor. We have the preprocessor. It's nothing but the preprocessor, and then what we have last we have the model. Okay, we have the lr with smooth. Okay, now after that I'm going to dump it out. Let's say joblib dot dump our model, and let's giving here one name. Let's call our model dot pickle, or you can say joblib because we have this joblib. You can give the pickle or joblib, whatever extension you can give it here. Okay, and our model is stored on that. You can see model joblib is stored, and also our submission file as well. Okay, so now what I can do, we're simply going to creating here the web applications using the Flask framework. Okay, so let's try to go on the VS Code and try to creating our application and testing it out with the custom input. Let's try to go on that. Well, so now it's time to creating here our web applications using the Flask framework, and I already wrote the coding part here. You can see here we have a file called app.py. This is nothing but my server file, and I'm going to do the Flask code. And also you can see here inside this sections, you can see here a folder called templates, and inside this template I have all of my HTML file, index.html and result.html. So now what I can do, first I'm going to run in these applications. So I'm going to simply going to running this out, and after that I'm simply going to make you understand that how the UI is building, as well as that how can we take in the input from the users, as well as how can I get the output, right? So what I can do, I am simply going to follow this link, just follow link, and it will open in this website that you can see a stroke predictions using machine learning. This is nothing but one heading. Okay, and after that we simply having one text in a paragraph format, then having a label called user input features, and having some text box with input. And you can see here this is having some drop down. You can select, then you can say hard this is yes or no, or whether it's marriage or no, or smoking or formerly smoked or smokes or unknown. And also you can see here it having the urban. Okay, urban, it's nothing but the residence area, and also the work type. Is it you're a private employee or the self-employed, the government job, or the children or never work. Okay, so yeah, we're going to making this a full UI, and after that we're simply going to make it functional using the Flux. Okay, so let's go on the designing part first. So that's our designing part, index.html. So we're simply going to actually creating here one HTML template, and inside that you're going to using here the bootstrap. So for that you need to adding here the CDN for the bootstrap, And then after that, I'm simply going to creating here one container. Okay, container of empty 5 and having one text that's called the stroke prediction using machine learning. This is nothing but the heading that you can see on here. And after that, we're having one paragraph tag, and also making this tag should be justified so that it will take in the exact position, exact the size of the text, as well as it should be in the center. And then we're simply going to giving some text of the death stroke is the second leading cause of death globally, like that. Okay. After that, we're creating one div, and inside the div, we having one form tag. You can see form tag, and method is nothing but the post method. Okay, this is so important because when you're taking the input from the users, you need to call in this method called the cat method or the post method, whatever, right? And after that, you're giving here the number of grow is gap equal to true, and you're giving here one text in h4 tag. That's called user input features. And after that, what you have, we having one deep, and inside this deep, we having one sections for the label is called h. And if I see this one, you can see here h. Okay, if I actually hover over here, or if I click on here, it will activate it. Okay, so for this one, we're taking one input, and type is nothing but number, and you can give them some bootstrap class. And also this name is important. Name is important. It's called age, because using this name we can taking the input from the users, and we can implement it in the Flask application. And after that, we can giving here some minimum and the maximum value, and it's required. If you don't give it, it will give you the error, or it is not actually submitting. You can click the submit button. Okay, and after let's say doing the same thing for the select, we're simply going to taking one select tab, and inside there just clicking this name because it's conventional and it's very important to give that. And then inside the select option, you're going to say simply going to giving some option as a value is male and the female. Okay, so how the user actually selecting this one, and this value is automatically come into this name. Okay, and same thing for here input tag, and the input tag, and the options. Okay, and the option, and also they have the options, all of the things you can see, never smoked or smoked, whatever. Okay, all of the things is coming up here. Okay, because the BMI, the type is submit. Okay, then how you actually use the type in the submit button is to actually predict the stroke likelihood. Just how you clicking this button, so this form is automatically redirected to the next page uh, inside our result.html. Okay, if I go on, let's say give the age is 32, let's say give it here the male, average glucose let's say 78, let's say hypertension let's say yes, and heart disease let's say no, and never married let's say yes, and urban okay, and never smoked let's say making formally scoped, and worked let's say self-employed, and BMI let's say 31. And if I click to here, and you can see it's not likely. Okay, and let's say if I selecting here, let's say age is nothing but let's say 56. Okay, and gender is nothing but let's say male, and average glucose level let's say 67, and hypertension let's say it having hypertension, it having also have the heart disease, it's even married, yes it's also married, and it is from rural area. And also you can see here let's say smoked, or let's say he's an private job, and also BMI let's say 34. And if I click on here, you can see likely, that means this person is having the a heart disease. Sorry, heart, not heart disease, actually it having the possibility of the a stroke. Okay, so you can see when I clicking on this one page is appeared on here, where you're going to see that the person having the stroke or not. Okay, this is the result page, and you can see it's just taking the input from the this app.py file, and it will showing this result on here that you can see on the application testing. So I simply go on the app.py file, and after that, let's understand about that what actually happening here. So first you import here from Flask, you input the Flask random template and the request. And request is needed just because of we need to take in the input from the users, and also import the pandas as the PD, and as well as input here the job lib, because you need to also load our model. And after that, we're simply going to creating here one app using app equal to Flask underscore name, and then we're simply going to load our model. This called a stroke model. Okay, joblib.load and model.joblib. And after that, what I can do is simply going to creating a route. This is not one for the initial route, and we're simply going to give here two methods. One is the get method, and another one is the post method. So in our applications, in our index.html, we have the post method. I mean, user can taking the input. Okay, I mean, user can give the input. Okay, we can take it. So if the request or method is nothing but post, then we simply going to taking the input from the users. You can see we can take in the input from the users and try to convert it in the lower manner. Okay, that's been based on the name. If I go on that, you can see here we have a name called age. Okay, we have a name called gender, we have a name called average glucose level. Based on that, we actually taking the input from the users. And gender, you can see gender, and now age is converted into integer. You can make it on the float as well, but age cannot be the floating point number. Okay, as well as the hypertension of the heart disease cannot be a floating point number, because you need to also convert them into the numbers as well. And also you can see for the email minute, we're simply going to convert them into the lowercase letter. That's mean user selecting here the yes, so it will be converted to yes, yes, it should be the lowercase letter. And also work type and the residence type and the average glucose, BMI, and the smoking status. We're taking this BMI in a floating point number and also the average glucose in a floating point number, because it should be the floating point number. BMI can be 31.56 like that, or glucose can be 78.23 like that. So that's why you're simply going to typecasting it and try to convert them into floating point number. That's when you're taking the input from the users. Okay, and after that we also doing one mapping for the work type, because work type can be the government job or the children or neighborhood or the private, because this is nothing but in our data set. That's why I need to also mapping this out. We can show the user, let's just say if I go on the application, then you can see we can show this one as a how is it, we cannot show this one as a cop job like that. That's actually showing in our data set. So that's when how the user selecting here the government job, it will automatically changes to the gov job based on my data set. Okay, and also children is children, never is for private. Okay, and after that we're simply going to do the same thing for our applications that we how actually building our petty system. They actually do the same thing. If I go on here, then you can see you do the same thing. You can see here we're taking one single input from the users, and after that we're simply going to convert them into data frame. And if I go on that, you can see we're simply going to call these functions called the predict input. And if I go inside this predict input, then you can see first it will actually taking the input and convert them into the data frame that you can see. And after creating the data frame, you can see after that data frame, we're simply going to pre-process it. Okay, we're simply going to pre-process it. Then you can see we're simply going to taking this encoding column, encoded column, and the numerical column, because we need to pass it is inside our features. Okay, so taking it from our model, because when saving this one, we having our encoded column, we have our numerical column, we having a preprocessor and the model inside our job lib. Okay, inside our same model. So when we are going to passing our input df, so our input df is nothing but coming one single input. Now we can simply going to passing here inside of the x, and now the x is nothing but taking the numerical column and the encoded column. So that's how it's going to separate this one. After separating this one, we simply going to taking this preprocessor, and using this preprocessor, we simply going to creating here our input df, and simply going to passing this input df inside our x, and x is nothing but going to inside our stock.model, going to inside our predict. Okay, that's our model, because in our model we having our encoded columns, we having our numerical columns, we have our preprocessor, we having also our model. आई एम टोइंग एक्चुअली गोइंग टू स्पीडली, बिकॉज वीडियो काफ़ी लंबा हो चुका है, इसलिए मुझे भी मन नहीं कर रहा है, भी थोड़ा बुखार भी हो, इसलिए खाना भी खाना पड़ेगा थोड़ा. Then after that I'm going to return here the predictions. Simple. See, simple. We're just creating here, we actually import here some library, creating one app and loading our model, and after that we're simply creating a route and taking the input from the users based on this index.html file as from the name. And after that we're simply going to map through all of the working, because we have our this gov like that in our data set. And after that simply going to creating one single input and passing to insert this predict method, and this is the predict method, and we simply going to creating here data frame, and you start here the encoded column and the numerical column, and then you actually start the preprocessor, and after that preprocessor we're going to transform it our input data, and after that we're creating here our x features, and we simply pass it inside our model, and this model give me the predictions. If it is 1, then we're simply going to say that it's likely to be a stroke, otherwise it's not likely to be stroke, and store it inside a result, and this result is passing to the parameter inside of a result, and after that this result is taking it here and showing it in our applications. Simple, super simple, super simple is it. Okay, it's so now let's go on the application again. That's our application. If I go on ahead, you can see this our application. You can give any kind of name, let's say 56, and let's say male, average glucose, let's say 78, hypertension, let's say high hypertension, heart disease, yes, hyperdisease, ivermectin, yes, urban, smoke, let's say smoked, and let's say it is a government job, and let's say BMI, let's say 34, 34 can really happen, 32, and if I click on here, okay, this sign can be reached. I hope so it will actually restart the application, I hope so. Okay, just what. Okay, invalid syntax. Okay, this is not. Okay, I think I need to save in this out, and I need to running this application again. Let's run it again, and after that you can use it. Okay, because it having some problem on that. Yeah, it will restore the server. And now let's go on that and let's try to test it again and go and follow link, and let's give it the same thing. Let's say it's nothing but let's say 60, and mail let's say average global, let's say 78 point let's say 89, and hypertension, let's say hypertension. Hard disk, let's say yes, and even married, let's say yes, and urban, okay, smoked, or let's say he's a government job, and BMI, let's say 32, and click on here, and it is likely it likely to having the stroke. Okay, if I go back and if I using here the simulator, the mobile simulator, and after that what I can do is simply going to, you can see here the applications in the uh, ipad in ipad, and you can make it in a Galaxy tab. You can see in the Galaxy tab how it look like. You can go on the iPhone 13 Pro, you can see how it will look like. And then you can also see in the MacBook Air how it look like in the MacBook Air. And you can also see here the iPad mini, in the iPad mini how it look like. And you can go on the Apple Watch as well, you can see in the Apple Watch how it look like. You can see, you can take the input from the users and you can also predict it out. Okay, and Galaxy Float too, you can see here how it will look like. Okay, so this is how the full application is built up, and how you can actually creating this kind of uh, machine learning model. Okay, so that's it for today now, and hope you enjoy this full tutorial, and make sure to subscribe our channel for more update, and as well as share with your friends, and also pray for me, thoda bukar ho gaya cough. Okay, pray for me so that I can make this kind of tutorial. Okay, so thank you and bye bye.